as a quick review, we have so far covered measures of center. Remember, this was the mean, median, and the mode, the three M's, okay? We've also covered measures of variability. This was the range, the variance, and the standard deviation, okay? The last thing we're going to look at is called measures of ranking. How does one value rank against all the other data points, okay? For example, you take a test and you get an 88%. How did you rank against all of your classmates? What percentage did you score above? How many classmates did you score above? And what percentage did you score below? How many classmates did you score below, okay? This measure of ranking is called a percentile. And again, let's show you just really quick, kind of an example of a percentile. So let's say that you score on a test. Let's say that the maximum score on an exam was a 95%, okay? And let's say that the minimum score on an exam was a 63, okay? And let's say that you scored right here, and let's say that you scored in the 80th percentile. 80th percentile. That means you scored above 80% of your classmates. You scored higher than 80% of your classmates, but you scored lower than 20% of your classmates. Does it tell you what your score is? Nope, the scores are irrelevant. It gives you your ranking compared to your peers in the course. You are in the 80th percentile, not percentage, percentile, okay? So percentile is a measure of your relative ranking compared to everyone else, okay? There's a couple other rankings that we're very interested in, okay? And we just gave this one as an example with the 80th percentile, but let's talk about some specific values. You've got the maximum, and the maximum actually is the 100th percentile, right? Like everybody scores below the maximum. And the minimum is the 0th percentile. I'm putting percentage in here. I can't do that. The 100th percentile, okay? And the minimum is the 0th percentile, okay? There's another value that you already know called the median. The median. And the median is the 50th percentile. That's the number in the middle, right? 50% of the values are above it, 50% of the values are below it. That's the median, okay? It basically takes the data set and divides it into two halves. But there's two more percentiles that we're interested in. We would like to know what is the 25th percentile. That cuts the bottom half in half, right? And also we want to cut the upper half in half. And that would be the 75th percentile. Okay, now for the minimum and the maximum, we just call them minimum maximum. For the median, we just call it the median. But for the 25th and 75th percentile, we have special names for them. We call this Q1 and we call this Q3. It's the first quartile. It's the first quarter. Because you'll notice when we do these percentiles with these specific numbers, we break the graph up into four parts. 1, 2, 3, 4, right? We break the data into four quarters. We break the data into four quartiles. Get it? Quarters, quartiles, okay? And so the minimum is the 0th quartile, if you think about it that way. And then we have Q1, which is the first quartile. That's the 25th percentile. That's the first quarter of data, okay? Then we have the median, and really you could call the median Q2 if you wanted to, but no one uses Q2. It's just easier to say median. And everyone's like, oh yeah, I know what the median is. You say Q2 and people are like, well, what are you talking about? Q2, what do you mean? Q3 Q3 is the 75th percentile, or the third quartile, the third quarter. And the maximum, you could actually call this Q4 if you wanted to, but nobody calls it Q4 because it's easier to just say the maximum. Okay. So these five numbers create something called the 5-number summary. So you have your minimum, your maximum, and your median. These values, we've already calculated these previously, but now we have two new players, Q1 and Q3. So if you take these values and you put them on a graph, you can create something called the box and whiskers plot, or a box plot. So this is your 0th percentile. This is your 25th percentile. This is your 50th percentile. This is your 75th percentile. And this is your 100th percentile. But it breaks the data into quartiles, and it kind of gives you an idea of how the data is distributed. When you look at this 5-number summary, you can take a look at Q1 and Q3, and this distance, the width of this box right here, from the 25th percentile to the 75th percentile, this is called the IQR, the interquartile range. Quartile, because it's Q1 and Q3, inter, because it's between the two, and range, because it's Q3 minus Q1. So the width of this interquartile range is important because, and here's the big kicker, it helps us mathematically define an outlier. I know previously we just kind of said, oh, if a point's far away, it's an outlier. Now we're going to give you the formal mathematical definition of an outlier. So this is what it is. If you take Q1 and Q3 and you take this IQR, this distance right here, okay, and you multiply it by 1.5, and then you add that to Q3. So this value is Q3 plus 1.5 times the IQR, that interquartile range, the distance between Q3 and Q1. This is your upper outlier fence. Any data points that are greater than this value are outliers. By mathematical definition, you have an outlier. If you are to the right of this fence, you're an outlier. If you're to the left of this fence, you're not an outlier. Okay? We do the same thing on the other side. So we start at Q1. So again, this is Q1. And what we're going to do is we're going to take Q1 and we're going to subtract 1.5 times the IQR. And this is the lower outlier fence. And any values that are to the left of our lower outlier fence, any values out here, these are officially, mathematically outliers. Okay? And so the definition of an outlier is based on this IQR, this interquartile range, which comes from percentiles and Q1 and Q3. So here is our data set. And do I want to give this data set a name? Named ranges. Yeah, we called it Sue, okay? So this data set is Sue. Everybody meet Sue? Sue, say hi to the gang. Okay, let's find out some information about Sue. So the minimum, the maximum, and the median, pretty easy to do. We've already done this, right? So equal min of Sue. That's the minimum value. The maximum value equals max of Sue. Okay, and the median equals median of Sue. There we go. There's the minimum, the median, and the maximum done. Boop. We've seen this before, okay? Now for the new formulas. This is quartile, okay? This is finding the quartile. So we're going to say equals. And guess what the formula for quartile is? Yeah, you guessed it. It's quartile. Quartile. Now you have to have two inputs when you do the formula for quartile. First is your data set. And that's pretty easy. The data set is Sue, right? Then you have to enter a comma and tell the formula what quartile you're looking for. Is it Q1? Is it Q3? And we're looking for Q1. So we'll type a 1 and then an end parenthesis, and there is the first quartile of Sioux. This is the 25th percentile. And if you wanted to write this over here, this is the 0 percentile, the 25th percentile, the 50th percentile, the 75th percentile, and the 100th percentile. So if you wanted to write that percentile, just to help you remember what we're dealing with here, okay? To find Q3, it's the exact same thing. Equals QUARTILE, parenthesis, quartile of what or whom? Quartile of Sioux. And what quartile are we looking for? Quartile number 3. Now you'll notice these numbers are sequential. The 0th, the minimum is 59.4. Q1, the target below which 25% of all the test scores fall, is 73.7. The median, the 50th percentile, below which 50% of the test scores fall, is 80.3. Q3, the 75th percentile, below which 75% of all the scores fall, is 82.7. And the maximum value is 91.6. We then find the interquartile range by subtracting Q3 and Q1. So there's our RQR. And then finally, the last move, where are our outlier fences? So for our lower fence, we're going to say Q1 minus 1.5 times the IQR. So any score below 66.2 is an outlier. Let's find the upper fence. Equals Q3 plus 1.5 times the IQR. Now, again, this is random. Sioux is a random data set. So as I refresh, you'll see that all of my test scores recalculate. But because we built this algorithmically, all of these values recalculate as well. So when we look at Sioux, are there any outliers in this data set? Does Sioux have any outliers? So here is the lower fence. So any scores below 67.1 are outliers. Do we have any scores in Sioux below 67.1? And we say, no, there are none, because look what our minimum is. Our minimum is 68. That's the lowest score in the data set. So that is well above the 67.1. So there's no outliers below, okay? No lower bound outliers. Are there any upper bound outliers? And let's take a look. Well, our fence is at 91.1. So any scores above 91.1 are outliers. Do we have any scores above 91.1? Oh, yes, we do. The maximum, 93.4, is on the other side of our outlier fence. And so that means that's an outlier.